was that Sweet's like music?
Yeah,
Oh,
Sweet was partying.
oh, oh, wow.
Good morning. I guess if this proposal gets accepted, the next EC course will be about how we need to forget everything we learned about fungible tokens. And yeah, my God, BZ, I am not a fan of that change at all. It's so, I don't know why they're doing that. It's bizarre to me.
Yeah, it's super annoying because I just like wrote so many contracts, and I'm like, really? I need to like redo them all. Like, I might as well not deploy them and just wait because like, what the fuck?
Yeah, literally. I mean, not to mention that like the changes that they're asking for, like they're not, they don't even make any sense. Like they're for some reason they're trying to like basically what happened just like a couple months ago. A lot of people like requested that an NFT contract supports multiple like types, but no one really like backed that up. But I think they just went with it for some reason, and I don't know why. So it's very strange. But yeah, if they end up accepting that, then we'll be definitely changing this course round in a few months. Sure.
Yeah, and I'll definitely have to attend because it's yeah, it's quite different. Like no collection in the NFT contract anymore, and
Yeah,
yeah.
I mean the thing is that they designed it so that you can have that. It's just that like they're gonna be like basically
Oh
doing
yeah.
yeah, like it's weird.
On the line, the most you can go home with is
So,
70
but
singles.
do you need us to set up a collection then? Like some NFTs don't need a collection and some do, right? Or
Well, the thing that they're doing is yeah, like the like if you want to set up your own collection because you want to have like certain functionality, you can do that. But if you don't like if you don't want a collection, then you can just use the generalized one.
that would mean that generally, if you have a generalized collection, someone could just like keep spamming you with NFTs and like make
Hmm.
sure that your storage would well nice.
Yeah, exactly. I mean that's the weird thing, right? Like although they're thinking about adding preconditions for like certain NFTs that people can trade around, but I just think it's a really bad decision because there's no benefit. There's only downsides to it.
Yeah, yeah. I think they are looking too much into like Ethereum and how OpenSea have been doing it with
Mhm.
Ethereum. Then
Yeah, yeah. All right, well, welcome everybody to the workshop. We're just talking about some stuff that's happening to the NFT contract, but we're not there yet in the academy. We're still at square one, and this is the first workshop for this boot camp. So don't worry if you don't understand the stuff yet. We're going to be walking through some of the basics today to help you in your journey. We'll get started in like maybe 3 to 4 minutes just to give people time to come in. But if you have any questions, feel free to ask. And after this workshop is over, I'll also open up for Q&A in case anyone has any questions. I see Ashley is here. Everyone say hi to. Oh, also yeah, we're talking in the text channel. But yeah, everyone say hi to Ashley. She's one of our instructors. We have Bruce as well. Everyone say hi to Bruce. Snowmobiles is here. Hey, Snowmobiles. Is there an instructor that's not here? Oh yeah, I think Bam. Bam's probably busy. For those of you that don't know, Bam, who's one of our instructors, recently is working at the Dot Find team after graduating from the academy. So, congrats to Bam. We'll see if he joins. Anyways, what's up, Bread? How you doing? What's up, cheeky lemur? Lemur, right? Yeah, lemur. Cheeky lemur, nice. So this is record and rewatchable. It definitely, yes, it is cheeky lemur. So don't worry if you have to drop off early. It's totally fine. Welcome, Davon. Good to have you, Davon. Yeah, Generous Kid back at it again. Generous Kid, weren't you here for last boot camp? I love that. In rotation, good to have you. Ola Banji, good to have you. Q2 Thek, what's up, Q2? Raven, of course. Snowmobile's our instructor. Ooh, we got Spitfire Sparks. Hey, Spitfire. Glad to have you here. SSEO321, what's up? What's up? We got Sweet blasting music and partying away. Thanks for joining, Sweet. And we got Trev. What's up, Trev? Sweet with the crying emoji. Oh, I love it. No, I'm just kidding, Sweet. You can blast the music all you want. So, and look, so actually, so it's pretty interesting to all of you. So for everyone that's typing in the chat, if they have like the little academy logo next to their name, that means they already graduated. So SWT and BZ are sneaks because they've already done this boot camp and they're coming back for more. So I love it. Davon's multitasking. What's up? Oh, we got W Falcon here. What's up, W Falcon? We got Big Daddy E-Rock too. Nice. All right, so we'll get started in 1 more minute just to wait for everybody. I want the number 0 float. Oh, true, BC. I have to do that. I have to do that. You're right. Oh, wait, yes. Let me configure that right now, actually. Thanks for reminding me. That's a great idea. We should have a float for this workshop. Definitely, definitely. All right, what are we going to call this? Boot camp. What is it called? Cadence. Wait, what's it officially called in the Academy site? Beginner Cadence Boot Camp. I don't want to name it that long. That's such a long name. What can we name it? Yeah, okay. Beginner Cadence Boot Camp. May 2022. Workshop number 1. Event URL. It's our Discord, of course. My official first session. Nice, Slackhash. I want the number 0 float. You all know I'm claiming that, so don't even think about it. Of course I'm getting that one. Actually, you know what? I'll configure this at the end. That way we don't have to sit through this. But all right, we'll get started. So welcome, everybody, to the Beginner Cadence Bootcamp. This is the May 2022 version. So we actually already did this bootcamp last month, but we're doing it again for all of you. And we're super happy to have you. Thanks, everyone, for signing up. And yeah, let's just get rocking and rolling. So if you started the bootcamp already, you've noticed that we're working from this repository called the Beginner Cadence course. And there's a couple chapters here, right? This is all the content. It's already all out. So technically, if you just went through and did all of these, you'd be done. But, you know, it'd probably take you some time. But today, we're going to start off early. You know, I'm expecting that no one here has any real experience with coding or any experience with blockchain in general. So don't worry, there's no prerequisites for this. And we're going to be going over all of Chapter 1, which is just these 2 days. And we're also going to be going over the first couple chapters of Chapter 2. So just day 1 and day 2. So with that, yeah, let's get started. So let's start with Chapter 1, day 1. What I'm going to... Oh, I have to share my screen. Oh my god, I'm not sharing my screen. Thanks, BC. Yeah, so okay, so what I was doing is I was just hovering over all of these chapters right here. So the way these workshops are going to work is I'm going to walk through some of the content together, and then I'm going to ask if anyone has questions, and then we're going to usually jump into coding. So for this workshop, because Chapter 1 has no coding at all, we're just going to walk through it together. We're going to answer the quest together, and then in Chapter 2, we're going to dive into some coding, and I'm going to do some live coding for all of you to sort of follow along. All right, so let's just dive into Chapter 1. So Chapter 1, I'm assuming, you know, maybe some of you have read through this already, but if you haven't, you know, this is sort of talking about like an introduction to blockchain, right? So what the heck is blockchain? Of course, I give you like a little introduction up here about me, but, you know, who cares about me, right? All we care about is blockchain. So just, you know, sort of skimming through this, you can read through this on your own if you want. It's a pretty good explanation. But what is the blockchain? Well, put simply, it's a big like storage network. The blockchain is really just a bunch of data that's stored between a lot of computers, right? Raven says, "Who cares about God?" True. No, but the blockchain is really just a huge, you know, data center you can think of. But the trick is that it's decentralized, right? So it's a data storage that's shared between a lot of different computers. So there's 4 main points here about what the blockchain is. One is that it's open. So one characteristic of the blockchain is that anyone can interact with it. There's no restrictions. So, you know, I can interact with it, you can interact with it, we can all interact with it. A second thing is that it's decentralized. Nobody owns it. So there's no central authority that's dictating this kind of stuff, right? No one's saying that, hey, you can't use the blockchain, because if I have a wallet, I can use the blockchain. It's a database, which means you can store information on it. So that means I can store my favorite number, my lucky number. I can store my name. I can store my NFTs on there. I can store anything I want on the blockchain. And, it's also public, so anyone can view the data on it. So this is a really important point because one thing that's really important is that you never, ever, ever, especially when we start talking about smart contracts, you never want to store private information on the blockchain. And the reason for that is because at any point, someone can read like if you put your passwords on the blockchain, anyone can read your password. If you put your date of birth, your social security number, and, any private information, you never, ever, ever put on the blockchain. It doesn't matter what you do with your smart contracts, which we'll talk about in a second. It's always public for everyone to read. So always be careful of that thing. So, again, you can read through the rest of these, but we're going to go right down to smart contracts. So does anyone have any, initial questions about what the blockchain is? And the reason, by the way, that I'm being sort of vague about what the blockchain is because we're going to learn more about this as we go. And I think the best way to learn is to sort of just jump into code and start working rather than read through a bunch of boring text. So if there's no questions, then we'll sort of dive into what smart contracts are. Thanks, Merab. All right, awesome. So yeah, the blockchain, it's an open, decentralized public database. That's, the short thing that you really need to know about the blockchain. And, for this bootcamp specifically, we're going to be talking about the Flow blockchain, right? So there's Ethereum, there's Flow, there's Algorand, there's Polygon. But for this bootcamp, obviously, we all care about Flow. So what are smart contracts, right? Well, smart contracts are, the focus of this bootcamp. We're not really going to be building dApps. This bootcamp more focuses on Cadence, which is the smart contract language for the Flow blockchain. So what is smart contracts and what is the smart contract language? Well, smart contracts are basically like a middleman. They're a way for us to interact with the blockchain, right? It's essentially, in one word, it's a rule book, which I put right here. It's a set of rules that allow us to do certain things on the blockchain. So, for example, right here, I write, if I want to make an application that allows users to store their favorite fruit on the blockchain, I need to make a smart contract that has a function anyone can call. Someone can write in their favorite fruit. It stores that on the blockchain, right? So a smart contract is how we actually interact with the blockchain. And of course, a smart contract is actually written in code. So that's what we're going to be coding throughout this entire bootcamp. We're going to be coding smart contracts, and more specifically in the Cadence programming language. So why do we use smart contracts, right? Well, one thing is they're very fast, they're efficient, and accuracy. So smart contracts are fast, and there's no middleman when it comes to smart contracts because they almost act as that person. There's no paperwork. If I want to update the data on the blockchain by using a smart contract, I can just do it. I can just call that function whenever I want. There's no one telling me I can't. And I don't have to get approval, from my parents or my bank. So one thing I'd like to mention is that, like, when we think about right now, when we think about banks, when you want to transfer like a large amount of money, your bank has to approve it. They have to, you have to go through a whole legal process. On the blockchain, you can do whatever you want. If I want to transfer 1,000 Flow token to BZ, which I would never do, then I can do that, right? I can transfer Flow token whenever I want. So that's one thing about the blockchain, right? You have complete control over your assets. And second, which is probably the more important part, is the trust and transparency aspect of the blockchain. They're extremely secure, right? So if you write smart contracts in the right way, they're very, very, very secure. And if you do write them in the right way, they're impossible to hack or alter the state of the blockchain in ways that you don't want, to happen. But, this leads us to and also, the transparency aspect is that all code is, available on the blockchain. So if I want to know what code I'm interacting with, I can always see it. So it's never hidden from me, which is a really good thing. But, of course, there's a lot of downsides, and we're going to be working to fix some of these downsides throughout this bootcamp to make sure that none of you make these mistakes. So, one thing is that smart contracts are very hard to get right. They're not smart. So even though they're called smart contracts, they're actually incredibly stupid. And that's because you have to make sure that you're doing them the right way. They require sophisticated levels of expertise. And what that means is that, you have to be really smart when it comes to smart contracts as the developer. Because if you do something wrong, that's really bad, right? You've probably seen on Ethereum that, there's hacks all the time on Ethereum, right? And that's because people aren't writing smart contracts in a secure way. So it's really scary. Another one is that, smart contracts can be very malicious if the developer is mean. So technically, right now, and I'm not encouraging this, but technically right now, I could write a smart contract that just withdraws all your Flow token from your account and gives it to me. And if I tricked someone into thinking that that was okay, I could steal all of your Flow token. So smart contracts are extremely scary. Straight up, they're very scary. And part of the reason that we're hosting these boot camps is because in June, Flow is actually going to allow anyone to add their own smart contracts. And so we really need to make sure that as a community, we're understanding what these smart contracts are doing so that we don't all get hacked. And, another hard part is that with smart contracts, you can't undo something. And, in other words, it's really hard to undo something. So if you make a mistake in a smart contract, it's really hard to fix it later on, which is probably one of the most complicated aspects of a smart contract. So are there any questions about what a smart contract is? And for the record, in the second part of this workshop, we're going to be writing our own smart contracts. So if you're confused about what these actually look like, that will be answered in the second half of the workshop. So I'm going to put like a little thumbs up here. And if you're all good, then thumbs this up. But if you're not good, thumbs this down. So if you're not good, then thumbs it down. But if you are good, thumbs it up. All right. Looks like everyone's got a thumbs up. Nice. Awesome job, everybody. We're all doing great. And don't be shy, by the way. If it's a thumbs down, don't be shy at all. So BZ puts a thumbs down even though he's already graduated. So BZ, don't be trolling me now. And it looks like Slackhash might have a question. So I'm going to wait to see Slackhash's question. Slackhash says, I think there's a case in ETH that cannot refund due to error in the contract. Exactly, Slackhash. So one thing, for example, right, is that on Ethereum, for example, there can be contracts where the person forgets, like literally forgets to add functionality that would give you your tokens back, right? And like I said, if you add that to the blockchain, if you put your smart contract out there in the public and you forget to add something, it's almost impossible to add that in the future. So that's why we have to be really careful about what smart contracts we add to the blockchain. All right. So I promise you we're almost done with the boring reading stuff part. We're going to jump into code and things are going to get a lot more exciting. So just stick with me while we keep reading through this for a second. Okay, so now we're going to get to transactions and scripts. So this is, another really interesting, part of the blockchain. But transactions and scripts are how we actually interact with the blockchain. So, if we think about, and we're going to talk a lot about this in the future as well, but if we think about, a smart contract as a rule book to actually interact with the blockchain, transactions, which are right here, a transaction is how you modify data on the blockchain. And a script is how you read data from the blockchain. So what's all that's important right now is that these two things are how we interact with our smart contracts. So I'm going to read through this just for a second. A transaction is a paid call. So all that's important right now is that, like, for example, if you wanted to put some data on the blockchain, that's a transaction because you're changing the data on the blockchain. But if you run a script, that's for reading data on the blockchain. Now, all that you have to know for now is that transactions cost money, or otherwise called gas, but scripts are totally free. So you never have to pay to read data from the blockchain, but you do have to pay to change the data on the blockchain, okay? Now, one thing I will mention is that, sometimes people ask about the differences between Flow and Ethereum. On Ethereum, gas costs, I think, are on average around $100, whereas on Flow, it's fractions of a penny. So on Flow, that's one of the great benefits of the Flow blockchain is to actually mint NFTs or to trade NFTs or to do anything on the blockchain. It barely costs anything, but on Ethereum, it's very, very, very expensive. Okay. All right. So that's what transaction scripts are. Just all you have to know for now is that that's how we interact with our smart contracts or our code. And then lastly, before we actually wrap up this day, is the difference between mainnet and testnet. testnet is basically an environment where everything is fake. And let me zoom this in a little bit so that we can look at this. And on testnet, everything is fake. So when you hear like, oh, I'm putting my smart contract on testnet, that means that it's not real yet. So there's no actual money involved. Transactions cost fake money. It's a good way for developers to test their smart contracts and applications before they actually put it to the public. And if something bad happens on testnet, no one cares because you can redo it whenever you want. So you can never actually make a mistake on testnet. However, on mainnet, things are very different. Because on mainnet, when someone says, oh, my project's on mainnet, what that means is it's the real deal. So everything is real. There's money involved. Transactions cost actual money. And if something bad happens, that's really, really, really bad because that means that that's permanent change. And so when your application is fully ready, then you'll put it on mainnet. So that's all we really want to talk about with testnet and mainnet. And then lastly, some people ask about what does the term DApp mean? Well, all it means is decentralized applications. So apps is for applications, and the D just means decentralized. And really, when people use that term, DApp, that just means it's an application in the Web3 space or in the blockchain space. And that's it. So to answer these 3 questions really quick, explain what the blockchain is in your own words. We went through that up here. It's basically, put simply, an open, decentralized public database. So just these 4 things right here. If you put that in your request, then you're totally right. For the second one, explain what a smart contract is. Again, I put another link here to help you out, but the smart contract section, it's basically a way to interact with the blockchain. That's pretty much it. So if you put that, then you're totally right. And if you listed these things as well, and maybe some of the hard to get thing, or some of the downsides, that helps your quest as well. And for the third answer, explain the difference between a transaction and script. I'm going to pause and actually ask all of you, what are some differences between transactions and scripts that I just mentioned? So if we can just get a few people to talk about that in the chat, then we'll move on to the next day. So Raven says paid/free. Exactly. So transactions are paid and scripts are free. And also, if someone has already said an answer, don't be afraid to say it again. The more answers, the better. So Spitfire says transactions cost money, gas, exactly, and change something. Yep. And the script is free to read and not change. You're totally right. That's a 100 for you. Good job. Brett says transactions cost money, scripts are free. Exactly, Brett. Great job. And FR Lab says transactions modify the blockchain. So great answers, everybody. Those are all right. Great job, everybody. Gas, no gas? Exactly. So transactions cost gas. All right. So we're going to move on to the next chapter, which talks more about the Flow blockchain and Cadence. So we just talked about like the blockchain as a whole and smart contracts as a whole, but we're going to quickly dive into Flow. And the good news is that this isn't that long at all. It's actually really short. So all right, so we all good to go? I'm going to put another thumbs up in the chat. And if we get any downvotes, then I'll quickly pause and answer some questions. But if we get some upvotes, then we'll go on to this day. All right. And for those of you that don't know where we're chatting, it's in the text channel. Oh yeah. So Numini, they're chatting in the text channel. All right. Looks like we got all thumbs up. Awesome. So yeah. So let's just jump into the next day. And then we'll already be done with chapter 1, which is awesome. So one thing I will mention is that all of these days, they have video content associated with them. So if you ever get lost in the text or you don't like reading text, you can always go to the video section and open that up in a new tab. And you can just watch my videos instead. So if you want to, you can just go through these videos instead. But if you like to read, then that's totally fine as well. All right. So this history lesson, we're not going to go through this in the workshop. You can totally read this on your own. This is more just of a history lesson about how Flow got started. Really quickly, the team that built Flow is Dapper Labs. And Dapper Labs, they were the creators of CryptoKitties. CryptoKitties broke Ethereum and is like one of the most popular projects ever and what started the whole NFT craze. But you can read more about that if you want. We're going to focus more on the coding part. And some facts about Flow that are helpful. It's much, much cheaper than Ethereum. It's very new, so a lot of things are still changing. And as well, there's barely any learning resources except for Emerald Academy. And yeah, NBA Top Shot, if you don't know, is also built on Flow. And during this bootcamp, we're actually going to be talking a lot about the smart contracts behind NBA Top Shot. So with that being said, let's just talk a little bit about Cadence, and then we'll wrap up this chapter. So what is Cadence? Well, Cadence is the smart contract programming language for the Flow blockchain. So if you've never programmed before, or maybe you have in the past, but you haven't in a while, a programming language is really just a bunch of, text that we put on a screen to make stuff happen, which is, that's coding. So Cadence is the smart contract, programming language for Flow. So Cadence is how we write our smart contracts. Now on Ethereum, it's called Solidity. So if you ever write Ethereum smart contracts, you have to know Solidity, but for Flow, it's Cadence. But Cadence is our best friend. Yay, we love Cadence. So here are some 5 things about Cadence just to go over. So one is that it's very safe and very secure. So as we go through this bootcamp, these are things to keep in mind as we go through this bootcamp. But one is that Cadence, even though it may be hard at first, Cadence is a lot easier than Solidity to learn. And in fact, because of that, it's a lot safer and a lot more secure, right? Because if a contract is easy to write for the developer, then by nature, it's safer because, we can read the code and know what's going on. Which leads us to our next point is clarity, right? So clarity, approachability, and developer experience. What I'll talk about here is that Cadence is really easy to read. So that's really helpful too, because if you're ever minting NFTs or you're interacting with a dApp or application, the ability to read the smart contract code is really important so you're not getting hacked. And lastly, it follows a resource-oriented programming model, which even I sometimes struggle with what this really means. But basically this means is that Cadence uses something called resources to represent your data. So I'm going to skip this for now, and we're going to come back to this in chapter 3. So we're not going to worry about this for now, but I'll mention this again when we get there. All right? So the quests for this day are, what are the 5 Cadence programming language pillars? Those are these right here. It's safe and secure, which just means it's really hard to hack a Cadence smart contract if you do it right. And the reason for that we'll talk about throughout the entire bootcamp. Clarity, approachability, and developer experience. Like I said, the code is really easy to read. So not only is it a great way for you to, know that you're not getting hacked and know that things are okay, but Cadence is also a great onboarding language for people into the Web3 space. So if you've been debating whether or not to learn Cadence or Solidity or other languages, I would definitely recommend learning Cadence because it's really easy to read and it's a great learning coding environment. And then resource-oriented programming is the last one. And then lastly, it asks you, what is your opinion? Even without knowing anything about blockchain or coding, why could these 5 pillars be useful? So I'm going to leave that to all of you to answer on your own. And we always like reading through some of your ideas. But that's all there is for this chapter. It's much more of like an introduction to the blockchain and what Cadence even means. And so, what I'm going to do is go back and we're going to, go to chapter 2. But before we do that, I'm going to send one more thumbs up in the chat. And I promise, I totally promise, if you have any questions, don't be afraid to ask, because this is definitely the time to do that, and we're all learning together, so don't be afraid. But yeah, just put a thumbs down if you have any questions at all, and also don't be afraid to unmute your microphone if you want to. All right. Sweet. So that was that was more of the boring part. So if you like to code and you like to get into the technical weeds, I promise that was probably the most boring it's going to be. The rest of the bootcamp is going to be really exciting, and we're going to be diving into code. So let's do it. Heck yeah. All right. So chapter 2, we made it. Chapter 2, this is where we actually start to write some code. So, coding. This, sometimes people get really lost. And like I said, there's a steep learning curve to all of this. So don't be worried if you have any questions. But what I'm going to do is I'm not going to read through this. I'm actually just going to start implementing this on my own. So let me just make sure I have this right. What are the quests here? Okay, cool. So this is what we're going to do. We're going to load up the Flow Playground. So if you haven't gone here yet, it's play.onflow.org. And I'm going to walk through basically this entire chapter, but with you live. So we're going to start from a blank slate. We're going to delete everything. So let's delete everything. And let's start in this account right here. So what the heck is even going on with this playground? Like, what does this even mean? Well, playground, remember how I mentioned the difference between testnet and mainnet, where mainnet is like the real deal and testnet's like the fake one? Well, we're on the emulator, which is even earlier than testnet. So when you're working on the emulator, that means you're not even at testnet yet. You're literally just developing. And then when you finish developing, then you can test it on testnet, and then you go to mainnet, right? So we're at the earliest stage right now, which means everything we do in here doesn't matter at all. So even if I write, please give me all of BZ's flow token, it won't do anything, right? Because it's just on emulator. So don't worry if you make a mistake in the playground. It will never actually impact anything, okay? So yeah, that's where we are right now. Now, you know, this may be confusing too. Like, what is this layout, right? What are all these, like, what does this even mean? And what is this transaction and what is this script? Well, what these tabs are right here these are dummy accounts for us to use. So you'll see there's account 1, there's account 2, there's account 3, 4, and 5. So Camerakin says, is anyone else not seeing the IDE? I'm still seeing the browser GitHub page. Oh, are you really? Wait, are any of you seeing the playground? Or is this, or am I not sharing the right thing? Oh, you see playground? Okay. That's weird. Camerakin, I'm not sure why you're not seeing the playground. Try to reload the stream, Camerakin, and see if that fixes it. So Vicken says, so it's like that Android Studio. I'm not sure what Android Studio is, but I'm sure it's very similar to that. Camerakin, yeah. I'm sure it's very similar to that. Exactly, yeah. Yeah, I would reopen it and try and see if that helps. So what are these, right? Well, we should sort of explain a little bit about what these actually mean. So, you know, for example, when I go to the Float platform, right? And actually, let me just go to my account really quick. See this long thing here, this address? I'm actually going to paste my address in the chat. That's called an address, okay? So when you see that like OX and then a bunch of random numbers, that's an address, right? Whereas on the Float playground, you'll notice that these don't really look like addresses because they're not the same length. But again, this is for testing purposes. So you can imagine that each of these accounts has their own address, right? And they're just 1, 2, 3, 4, 5, just to make it simple, okay? Now, in addition, each of these accounts is a different account. And, you know, to sort of explain where we put smart contracts, we put smart contracts into an account. And the way that we do that is we quote unquote deploy a smart contract to an account. So when I make a smart contract, I have to deploy it to an account, right? So that's why right now I've clicked on account 1 right here, this account 1, and I'm going to write my contract in here and then click deploy. And it's going to actually put my smart contract on the blockchain in this account, all right? So let's just go ahead and do that. So I'm going to type some code right now, and if you get lost, that's totally okay, but just stick with me. So what I'm going to do is I'm going to write some code just like this, very simple. Now, all this does is this makes a new contract. The way that you make a new contract is you say pub contract and then the name of your contract. So it always looks like this. It always looks like pub contract and then the name of your contract. And then you open up some curly braces just like this. And then inside of here is where we can add a lot of information about our contract. So let me actually, are there some helpful, did I put some helpful diagrams on here? Okay, no, I don't think I did. But you'll see we're at this step right now, right? We just made a blank slate and we're going to add some stuff to our contract right now. So inside of here, right, now that we have a new contract, we want to do some stuff, right? We want to maybe have some data, and then we want to have some functions that interact with that data. All right? So why don't we go ahead and let's just store like a greeting that just says hello, right? That's the most simple thing. It's just to make a hello thingy. So again, stick with me here. I'll explain it after I write it. But I'm going to write public var greeting is a string, right? And all I did here is I made something called a variable. Now, a variable is something that contains information. It holds data. So this greeting which I initialized by saying public var greeting. So for now, always write public var and then the name of your variable. And we said it has type string. So what string means is a string is basically just like, it's a word like hello or, like hello or goodbye or Jacob, right? What it's not is a number like 100. A number is an int, but this is a string. So it's like a word, okay? So that's what we mean by string here. Now, the way that we do that is we say public var greeting and then this little colon and then the type. So the type of it is string, right? Because we're saying it's a word. Now, some of you also, if you haven't programmed before, you probably don't know what these are. These are comments, which mean that like if I put 2 brackets ahead of a bunch of like a sentence, this isn't actually in the code. It's we call it commented out, which means it's not actually going to impact our program. So it's a helpful way to like label stuff. Yeah. Now, you'll notice that we get an error, right? What's this error saying? It's saying missing initializer for field greeting in type hello world. So it's complaining that we're not actually setting this greeting equal to any value. Now, the reason for that is because if we put this hello world contract on the blockchain, what would happen? Can anyone take any guesses? Like, would this be useful at all? Anyone have any guesses in the chat? Would this be useful at all right now? No. Exactly, nothing would happen. Yeah, exactly. Good job, everybody. Literally nothing would happen. And the reason for this is because we don't set this equal to anything, right? What is our greeting? We have no idea. It's empty right now. So in order to make sure that it's not empty, we have to do this thing called an initializer or init. Now, what this does, right, what I just put here, this is going to get run when we deploy the contract onto the blockchain. So remember, deploy, I'll actually write this right here. Deploy equals, so deploy is the same thing as when the contract gets initially put on the blockchain. So it's really important to know that, so like note, this init function only gets run one time ever. So once this init function gets run, it's never going to get run again, right? Because it only gets run when you initially deploy the contract to the blockchain. So the way that we set this greeting equal to a value is we say self.greeting equals hello, right? And now it's not giving us an error anymore. So what this code means is self just refers to this thing right here. It's saying, hey, this self means go one layer above, which is right here, and access the greeting variable and set it equal to hello. And that's it. So what's going to happen right now, and remember, we haven't even defined any functions yet, so there's no functions right now. All we have is data, and then we set that data equal to something when the contract gets deployed. So if I click on deploy, right, look what it says at the bottom. It says deployed to contract 0x01. So what just happened? Can anyone write in the chat what just happened when I click deployed? Magic. That's exactly what just happened. Magic. Yeah. Love that. Yep, magic. The contract got put on the blockchain. Exactly. The variable was set. Yep. Good job, Trev. The contract was deployed to address 0x01. Great. I love that explanation. The reason I love that is because you said it was deployed to account 0x01, which is really important, right? Because these accounts are still empty, but this one has the contract. Great. That's really good. Good job, everyone. So yeah, so 2 things happened. 1, it got deployed to this account, and 2, the variable was set, like Trev said, right? So that's really important. Now, and also remember, none of this is real, right? It's all fake. It's all in the emulator. So even though I deployed it to this account, remember, this is all fake. So you can't actually use this in like a real setting. All right. So if I want to now read, like, let's say I want to read what this greeting is, right? Should I go to transaction or script if I want to read it? Script. All right. Yep. Exactly. Great job, everybody. So we have to go to script, right? But before I do that, let's just note really quick. Wait, did we finish this? Oh no. Okay, we're almost there. So right now in the day, we're currently at this point, which is reading our greeting, right? So let's go to the script, right? And now we're here. So good job, everyone. Yep, we're reading it, so it's a script. So the way that we do this now is we have to, make a function to actually read our hello world. So inside of a script, it always looks like public function main, just like this. This is what it always looks like. Now I'm curious. I don't know why I don't have a image for this here, but I think it might be in the next one. Anyway, so yeah. So in order to do this, in order to make a function, it is going to turn off your microphone when you're not. Yeah. Does anyone? I'm not sure who you're talking to, Raven, but maybe someone has their mic on. But anyway, with a script, we always do this: public function, main. Yeah. Wait, where is that noise coming from? Not sure. Bam, if you see someone's mic on, mind just muting it. Anyway, so public function and then main, right? So this is called a function. Now what this does is, unlike this, if you're not familiar with coding, greeting is a variable. It stores data, right? A script, on the other hand, or a function runs some code. That's all it does. It just runs some code. Oh yeah, I hear that again. Okay, I muted it. Nice, we found the culprit. So the function actually, executes some code. So what we can do here is we can return hello world, and stick with me for a second. I know this probably won't make sense, but we're going to return hello world.greeting. Now what this means is we're going to go to the hello world contract, and do dot greeting. So we want to know what this greeting is right here, what this variable is right here, right? Now we know it's hello, but we're going to prove that. We're going to prove that to ourselves. So let's go back to our script, and you'll notice that, it's giving us a problem. Cannot find variable in the scope hello world. And the reason for that is because the script doesn't know what we're talking about, right? The script is saying to us, hey, what the heck is hello world? So in order to make sure that we bring our contract into the setting so it knows what contract we're talking about, we have to say import hello world from OX01, which is the account, right? Amazing. So now it knows what hello world is. Oh no, it wasn't you, Viking. Don't worry about it. It wasn't you. Numini says can't hear. I think that might be on your end, Numini. I think. But anyway, so yeah, so now it knows what hello world is, but it's giving us a different error. It's saying mismatch types expected void got string. And the reason for that is because when we return something here, this means that we want to return this back to the caller. So in our case, we're the caller, right? We want to know what this data is that it can print right here. All right. But what the problem is that in the function, we're not specifying what the type of this return value is. The way to fix that is we put this little colon here and then put string, and now it's fine. So again, just to walk through this, we want to read hello world.greeting, which means go into the hello world contract and look at this greeting string right here. So, and then we're going to return that to the caller. And so because we're returning, right, because this return is here, we have to put colon and the type of the return value, which is a string. And then we have to import hello world so it knows what we're talking about. Now, theoretically, if we were to execute this, look what got printed to the console. So if I zoom in here, look at this. It says, this is the thing that got returned. The type is a string, and the value is hello. So yay, we did it. See, that is the type in greeting right there. So I'm going to pause there for a second. I'm going to do another thumbs up thing. And everyone let me know if you're struggling with this or if this is good so far. All right, we got a lot of thumbs up. That's awesome. Cool. Also, I'll leave it a little bit more zoomed in case that helps anybody. Exactly. Yep. Yeah, Numini. It's also live on my YouTube if you wanna go there. All right. So it looks like everyone thumbs that up. So that's great. Good job, everybody. So everyone seems to understand that so far. So, okay. Now let me ask you something. So we know right? We know right now that a string, right? A string is like a word. It's like hello, it's like goodbye, it's like Jacob, right? It's some word, right? Or phrase, right? It could even be like I love chocolate chip pancakes, right? All of these things are strings. Oh yeah, that stinks, Cameron. Maybe it's the connection. Um, on the bright side, this will all be live. This will all be on YouTube after. So then, one other thing I want to talk about is int. So int, right, is a number like 10, 20, -10, 4, 3, 4, this huge number, right? This is an integer. So what would happen if I wanted to do this, right? Let's say I wanted to return 10. What's the problem now? Why is it giving me this? Mismatch types expected string got int. What's the problem with this function right now? String, right? Wrong type, exactly. So in order to return something, I have to put int here. And that's because now we're returning the right, exactly. Good job, everybody. So good, yeah, great job. So now if I click execute, it's going to print int and 10, right? So perfect. So a script, we don't even have to read from the contract. So in this case, right, I don't even need to import hello world because we're not even using it. But again, if we bring it back, now we're doing the right thing. So perfect. So if you understand all of that, that concludes this chapter. So in the quest, it says to deploy a new contract called Jacob Tucker, right? And to make a constant variable named is, and make it have the type string. So, and I write here, the reason here. So let's walk through this together. So it says deploy a contract to account 3 called Jacob Tucker. So let's go to account 3. Let's delete all this. And let's make a new contract called public contract. And what does it want us to name it? Jacob Tucker. So let's name it Jacob Tucker. That's me. Woohoo. I love that I get to make these quests. And inside of this, it says, inside that contract, declare a constant variable named is and make it have type string. So one thing I forgot to mention is this constant, right? What does constant mean? So let me go through that right now. So when we declare a variable, right, you notice we're going to talk about what this public means at a later point, but let's talk about what this var means. This var means that we can change this greeting whenever we want, okay? So var means we can change this variable at some later point, right? So if we wanted to make a function that changes greeting, we can do that. But let means it's a constant. So it can never be changed, all right? So if we had made this let, then that means we can't change greeting. So, more simply, what this quest is asking for when it says inside that contract, declare a constant variable named is, then, with a type of string, it's saying, hey, oh, I don't know what happened. That's weird. Got rid of some code. But it wants us to do this. It wants us to say public let because it's a constant, and then say is, and it wants us to be a string. And then, because I wrote the quest and I'm just trying to be funny, it says check that your variable is equals the best when you're executing the script. So what that means is in our init function, we need to say self.is equals the best, right? And then now when we deploy this contract, right, it's deployed, boom, and we can even see it's deployed at the bottom here. That way we can go down to our script tab again, click on this plus button, and let's just make a new function, public function main. It's going to return a string. And in here, we're going to return Jacob Tucker dot is. And what do I have to put at the top here in order to make sure that this isn't an error? How do I make sure that we can actually call Jacob Tucker here or look at the Jacob Tucker contract? So NGI says import. That's great. That's great. Anyone have any like a specific import the Jacob contract? Great. So I'm going to write import. Nice. And now let's look at this one. So it's import contract from address. So what do I put here? Good. Good. Great job. Import Jacob Tucker from OX03. And if I click execute, hopefully it'll work. Okay, so just for the record, yeah, I'm going to mention this really quickly. The Flow playground is super buggy. So if you ever run into errors, most likely it's not your fault. Because the playground's super buggy. the thing is, I reached out to the Flow team, and they're going to be fixing a lot of these problems soon. But if your code looks right and it's not working as expected, the chances are it's just because it's really buggy. So don't mind these errors for now. They should work. You'll see, like, I didn't change anything, and it's fine. So yeah, the solution usually is just a refresh, or to like make sure. Yeah, like just a refresh is really the only solution. Yeah, exactly, exactly. So Davon says, when Jacob Playground? That's a great question. That's a great question. Yeah, the Flow team is working hard on fixing that. But anyway, point is, you can see down here, it's the best. So if you get that to work, then you've completed this day. All right. So the last thing we're gonna do is talk about this day, and I promise you, it's long, but it's actually not that bad. We're only gonna add like one little thing to it. So that's it. Yeah. So how's everyone doing? I'm gonna keep doing these thumbs up because I think it's working well. And then I make sure that everyone's actually doing okay. So this is the last thumbs up we're gonna do, and then we're gonna do day 2, and then if we do that, then we're done. All right. Yeah, exactly, Ricardo. Yeah, so sometimes the code gets stuck, and you edit it, hit run. It's so yeah, I know, right? I actually reported that to the Flow team. They're looking into fixing that. So I think the solution to preventing errors is just to go slow. If you go really slow, it usually works. But anyway, yeah. So what's the problem with this current code? The problem is we can't change greeting. And the reason for that is because we don't have a function that allows us to change it, right? And this is part of the point I was talking about earlier, where I was talking about the fact that in smart contracts, there are rule books. So right now, this smart contract or this rule book doesn't allow us to change greeting. And if that's what we want, that's okay. But for our purposes, we want to have a function that changes greeting. So let's go ahead and do that. So just like we defined a function here, public function, and then the name of the function, as just for the record, for scripts, the function name always has to be main. Make sure of that. But in here, we can say public function, and let's give it any name we want. So let's say change greeting, right? And then inside of here, we're going to open up our curly braces, and we want to, change our greeting to something else. So let's say self.greeting equals goodbye. Okay? So what this is going to do is, when we call this function, right, we're going to say self.greeting equals goodbye, and it'll change the greeting to that value, right? So pretty easy. Now, one thing I want to mention is, what's going to happen, right? Why, if I change this to let, why is this giving me a problem? Anyone know why it's giving me a problem if I make this let? Nice. Look at all of you kicking butt. Let's go, guys. Cannot change a constant. Yep, it's immutable. Let means you can't change it, can't change it, can't change it. Great job, everybody. Awesome. So yeah, we want to change back to var. All right, wow, we got a bunch of rockstar students in here. So with that being said, if I go ahead and deploy this contract, and you can always redeploy in the emulator. So I deployed it again. Boom. This is the updated contract. So remember, if you make changes to your contract, you always have to redeploy it, right? Or else it's not going to change. So, and now, of course, I would ask this question, but I assume all of you know the answer. Because we want to change this greeting, we have to go to transaction, right? So we can't use scripts anymore. We have to go to the transaction. So inside of here, the way that we code this out is transaction, like this. And we have two things instead of a transaction. Actually, I think in this chapter, I actually include this in the notes. I do, yeah. So in chapter 2, you'll see that inside these little boxes, I put the outline of what they should be. So for script, it's public function main, but for transaction, I outline it here. So two things. We need something called the prepare phase. And I'll talk about what all this means in a second, but just stick with me. And we need an execute phase. So we're going to talk a lot more about prepare in chapter 4. So don't worry about this for now. In fact, yeah, don't worry about this at all. Just remember that if you're running transactions, remember to put this here. But again, we're not going to worry about this for now. Just go to the execute phase, and I'm leaving this out on purpose because it's too confusing now. So go to the execute phase. Now in here, we're going to actually run our code. So we want to run hello world.change greeting. right? And we're going to call it, it's a function. So we have to put these little braces here. And that is, we're calling hello world, that changed greeting, right? So if we go back to our transaction, giving us a problem. Now, we've already solved this problem, right? We have to import hello world from OX01, and now it's okay. So if we go ahead and send this, hopefully, okay, so it sent it and nothing was printed, right? So we assume that it worked. If we wanted to, by the way, we could put like log and then done, and then we know it's finished. So if I go ahead and rerun this again, see it says done because it went through. So perfect. And then if we go back to our script, hopefully, if we did things right, it'll print goodbye. So look, we changed it. Boom, goodbye. So we correctly changed it. Now, one thing we can mess around with, right, is inside of our hello world, let's say we don't want to change it just to goodbye. We want to change it to something that we pass in. So what we can do is we can pass in a new greeting right here. That's a string type. So right here, we can put new greeting. And what this will do is this will change our greeting to the greeting that we passed in. So now we can pass in any greeting we want, right? So let's go ahead and redeploy this contract. Boom. We deployed the contract. And let's go back to our transaction. And now look, it's giving us an error. Incorrect number of arguments, expected 1 got 0. It's giving us a problem because we're not passing in the new greeting yet. So in order to do that, let's do new greeting. And we can pass in, let's just say like our new greeting, okay? And what we can do is we can add this our new greeting to the transaction arguments. So I'm going to do all this, and then you'll actually see why I'm doing this, right? And now look what happened. So our new greeting that we're going to pass in is going to be our new greeting that's getting passed in through the transaction, and it's a string type. So what we can do is, inside this little box, we can type in, Jacob is the best teacher ever, and click send. And of course it's giving us a problem because the playground's being annoying. So let me just refresh the page. And yep, so you'll see there's like a little bug. So let me fix this. Man, I hope they fix these playgrounds before I have to go on to harder lessons. Let's just say like, yay, Jacob, right? So hopefully this is fine. Let's send it. Oh my god, they're annoying. I thought they're gonna fix the playground before this, but anyway, the point is that this would work, and then in our script it would now print Jacob yay because it changed the greeting. So hopefully they'll fix the playground bugs at some point. We don't have to go through this over and over again. But let me try one more time and see. Oh, okay, it worked that time. So I just typed in fas. Okay, go to our script. Let's check it. And now it's fas. So you get the point, right? It changed. Yay! All right. So I hope that made sense. And yeah, and just to sort of like solidify some ideas, if we change this to an integer, it would give us a problem, right? Because hey, it's saying we expected a string, right? New greeting is supposed to be a string, but we got an integer, so it's not going to work. So we want to change this back to a string again, and yeah. Now you also may be wondering, what does this mean? Like, why are there account signers on the other hand? Again, don't worry about this for now. We're gonna get to this at a later point. But if you're curious, what this means is that whoever we select here is the person that's paying for the transaction. So when I change this greeting, right, this costs gas, it costs money. So the person that's here is simulating who's the one paying. So in a real world scenario, right, you're the one paying, because you're the one signing the transaction. But in this case, it's whoever we just click here. So we'll get into this at a later point, and we'll dive into that later on. So Mayrab says, why does the playground give bugs when you type Jacob is the best teacher ever? Maybe it's because it's false. Maybe it's because the playground's saying that's false. But of course, we all know it's not false. We all know it's actually a fact. So, yeah, it's just the playground being buggy. Because of course it's a fact. Are we sure though? I'm pretty sure. I don't know about you, but I'm pretty sure. So I'm not going to go through this quest in this workshop because we're sort of running out of time. Oh, you don't, Ricardo? Oh, that's so hype. Oh, really? Oh, is that why I was putting extra quotes in? Oh, okay. So if I just do wef. Aha, that's so much nicer. So for those of you that were wondering why I was putting quotes in before, it's because in the old days of Cadence, you had to do that, but you don't anymore. So nice. That's exciting. So maybe as we go through this boot camp, you'll discover that actually I'm just an elder and I'm like that wise wizard that like keeps using old practices. Anyway, that's all I have. So I'm gonna do one last little thumbs up, and if you want to stick around, you're more than welcome to. Oh, I also have to do the float still. But if you have any questions, feel free to unmute your mic or ask in the chat. But let me make this float really quick. Oh, nice, it stayed. I came here for the float. I'm glad you're honest. I love the honesty. Beginner Cadence Bootcamp, May 2022. Workshop number 1. We're going to make it non-tradable. Get wrecked. Limited quantity. Time limit. So I'm going to allow you all a little bit of time to claim this. We'll set it till maybe like tomorrow. Secret code is going to be... what should the secret code be? Anyone have an idea? Wef. All right, probable. That's what we're going to make it. All right. So the secret code is wef. And we're going to create this float. No, Merab, I can't type in Jacob is the best teacher ever, because if I do that, it's going to give me an error. Right? Because it's false. He said. Oh my god. Yeah, also, I think what I'm going to do is, like, at the end of the boot camp, like, if someone has all the floats from all the workshops, I might give them, like, a special prize. I don't know, we'll see. I'm not 100% sure of that yet, but let's go to my events, and let's go to this one. All right, so have fun, everybody. Let's see who gets serial number 0. Actually, maybe I will. Wef. I'm going to beat everyone to it. Get wrecked. Get absolutely wrecked. I think I'm going to get 0. I can't wait to see who gets the other ones. Maybe we'll see who gets 1. So I'm going to leave this open until tomorrow, so if anyone watches it on YouTube, they can go and claim it. All right, which one did I get? Hey, I got 1? Wait, who got 0? What? Okay, wait, but how did anyone beat me to that? I'm actually confused. Wait, hold on. Wait, guys, we can figure it out. If we type /resolve, it was BZ. What? BZ, how did you do that?
BC is a very common name. I don't know who that guy is.
How that?
But
I love that. It's so entertaining to me that we can identify who the culprit is. We can just wow, the power of technology. But BZ, you're a speed demon. Oh my god. I'm actually in shock. That's so funny. Oh my god. All right, well, looks like we have 19 people have claimed it. All right, last thing, everybody. Everyone smile for the group picture. Yeah, everyone smile. Wait, let me zoom out. Okay, I guess I can't get everyone. That kind of stinks. But yeah, smile. Gotta take a little screenshot. Nice. Actually, let me see. All right. The phrase is wef. Miss the cut? No, I don't want you to miss the cut. Wait, I'll take another one. Nice. All right, now everyone made the cut. Did everyone make it that time? You made it, Trev. Nice. You made it. Oh, no, Raven, I'm going to add it there. I just have to make a new group. So yeah, let me actually, I can do it right now. So let me go to my group. So you'll see that this is for Emerald Academy. So I'm going to add that to this one right now. Although this is for like, yeah, I guess I'll add it to this one. Yeah. All right, so thanks everyone for coming to this workshop. I really hope that was helpful. Sorry if it wasn't. I don't know. I'm open to all feedback. Hope it was helpful. If it wasn't helpful, then you can scream at me on Twitter and on Discord. If it was helpful, then I'm so glad. And I'll see you on Friday. At what is it? 9 a.m. PST. So, if you can't make it on Friday, that's totally fine. Again, these are all recorded. And yeah, we're gonna kick some butt on Friday. Thanks so much, Spitfire Sparks, for the kind words. You're so welcome, Cheeky Lemur. Yes, you can, Ola Banji. Ashley with the rocket. Thank you so much to all the Academy instructors. Everyone, please remember to thank your Academy instructors for all the work they're doing. They're doing such an amazing job. Thank you, Raven. Thank you, Generous Kid. Thanks, Ricardo. You're welcome, Ola Banji. Thanks, Raven. Thanks, Square. Thanks, Trev. Thanks, Charlene K. Thank you. Thanks, NJ. Thanks, SSE. Thanks, Bread. Thanks, Mayrab. Thanks, Q2. Thanks, Rotation. Thanks, Slackash. All right. Bye-bye. Thanks, Davon. Bye, New Mooney. Where's Edinburgh Academy on Float? And thanks. I'll send that to you, New Money, afterwards.